Okay, so the last portion of this class is going over some of the trig identities. We'll try to go over as many as we can. So I will give you a guide that you can use, and you can, even if you don't like the guide that I use, you can find one usually on Google, or if you lose it, you can find one on Google. But the trig guides usually look like this. They have all the trig identities. I think these are all of them, if not most of them, ones we'll be using at least, especially for today. It shows the unit circle, which is very helpful. And it's helpful to also start to remember the unit circle because you will be seeing it a lot in trig and pre-cal and beyond that. It goes over, the trig ratios and their inverses, other reciprocals, and some other things as well. So for this video, we will be using the multiple angle identities, also known as double angle identities, which are right here. So let's go to the worksheet. So the worksheet says to solve each equation for the interval of 0 is less than or equal to theta, which is less than or equal to 2 pi. Well, if you were to say that in degrees, as you know by now, 2 pi is 360. So they only want the answers up to 360 because you can keep going, and I'll kind of explain that in later on. Okay, so here we have negative sine of 2 theta equals the square root of sine theta minus 2 sine theta. Okay, well, if you look at this here, sine of 2 theta is a trig identity. Let's go back here. Sine of 2 theta equals 2 sine of theta cosine theta. So let's replace those. And a lot of times when you're dealing with trig identities, you will be replacing the part of your equation with the trig identity. Let me see if I can get the theta symbol. Hold on. So we're basically solving for what theta is. And a lot of these will have multiple answers. So it's a little bit kind of like solving equations in algebra, but a little more challenging, of course. Oops, trying to type the square root button. Square root of 2. Okay, so negative, I'm replacing it with sine theta cosine theta. I'm replacing sine of 2 theta with the trig identity, basically. That's all I'm doing right now. So all I did was replace sine of 2 theta with its trig identity, which was 2 sine of theta cosine of theta. Now here I can do distributive property, right? And I would get a 4 sine of theta cosine of theta. And then I'm also going to move everything to the left-hand side. So when I do minus that 4 sine of theta cosine of theta to the other side, sorry, when I did the distributive property, this should have been a minus 4 cosine. Sorry, minus 4 sine of theta cosine of theta. So all I did right there was distributive property. Okay, so I'm going to add that to the other side, right? Just like solving equations, you add it to the other side. And then I'm going to minus the square root of theta sine of theta to the other side. So now combine like terms. These right here are like terms. You're now going to have 2 sine of theta cosine of theta minus the square root of 2 sine of theta. And all of this is equal to 0. So I should probably keep that there. So now you can factor. So, there's lots of algebra a lot of times in trig and moving forward. So you can factor. What do these terms have in common? Well, they all have sine of theta in common, right? So if I took out a sine of theta, I would then have 2 cosine of theta minus the square root of 2. And then equals to 0. So that means sine of theta equals 0. And I could rewrite it like this: negative square root of 2 plus 2 cosine of theta equals 0. Okay, so if you look at the unit circle, when does sine of theta equal 0? It equals 0 at 0 degrees and pi degrees. And that's your answer, part of the answer. For this one, we need to add the radical 2 to the other side. We then have 2 cosine of theta equals radical 2. Then you would divide both sides by 2, and you get cosine of theta equals 2 divided by radical 2. Okay, so if you look at the unit circle, where does cosine of theta equal? It should be radical 2 over 2. And it equals radical 2 over 2 at pi over 4. Actually, let me write it in red. At pi over 4 and 7 pi over 4. And that's your answer. So you're solving these using the trig identities, and in this case, you're using the multiple angle identities, which is here. So whenever you see sine of 2 theta or cosine of 2 theta, you're going to replace it with what it says over here. And that will help you get to your answer. So you really just kind of got to play around with these. These are pretty challenging, so they take getting used to. You kind of got to, just go keep practicing these to get better, just like you do when you first learn to solve equations. So there's also an app called PhotoMath. It's free. It's not the best unless I think you pay for it, but you don't have to pay for it. You can just download it for free. It will give you step-by-step for a lot of these, because sometimes it's good to have like a little math app to help you in case you are doing a wrong step or something of that sort. Okay, so for these, we're going to use the sum and difference formulas. So let's switch back. So I'm going to do number 9. We're going to use the sum and difference formula, which is here. So basically, whenever you've seen sine of theta plus, sine of something plus sine of whatever, you're going to use this. And in this case, you're going to use that. In that case, you're going to use that, and so on. So for the first one, we have sine of 4x plus sine of 6x. So a plus plus, we're going to use that one right here. So it helps actually print this paper out and use it when you're doing your homework. You can use that when doing your homework and tests. Usually teachers will let you use, they do not expect you to remember all these trig identities. That would be very cruel. They let you use a sheet to help you. Okay, so we're going to change this to the trig identity. If we did, we would get 2 sine of 10x over 2, cosine of 2, so 2x over 2. And how did I get that? Well, the trig identity tells you that you're going to add the numbers together right there. That's how I got 10. And then you're going to minus it for the other one. So if you look at the trig identity, it'll tell you. And then we're just going to simplify. That should be a negative 2x. Negative cosine of negative 2x, which gives you cosine of negative x. Okay, once again, if you look at your trig identities sheet, cosine of negative x is just cosine of x. So if you look at the trig identity sheet, it is under negative angle identities, it is called. Okay, so now we can just change that to cosine of x. Okay. So now it's kind of like solving equations. Let's divide both sides by 2. Right? That way that 2 right there cancels out. Anything divided by 0 is 0. So you have sine of 5x plus cosine of x equals 0. Now just separate them. Both of them equal 0. So sine of 5x equals 0 and cosine of x equals 0. Okay, so this one's easy. When does cosine equal 0 on the coordinate plane? It equals 0 at 90 degrees and 270. So basically for every 90 plus 180 times the number that you go around, that is when cosine of x equals 0. So basically what that is saying is if I were to plug in a 1 for n, I would get 270. If I were to plug in a 2 for n, I would get 180 times 2. I would get 360 is plus 90, which is 450. And then I would just keep going, you know, over and over again. So basically, if this is how many times you would just keep going, right? And you can plug in a 1 there, 2, 3, 4, 5. It can go on infinitely because here there's no interval. They said find all solutions. So you would write your answer like this. This is all solutions. This is the answer for every single solution that we could get. They're not going to have you list them out because that would take way too long and take forever. So then just write it that way. Okay, so for here, we have sine of 5x is equal to 0. So let's think. How do we do this? What would we do with that 5? Well, when sine of x, if you were to think of it like this, sine of x is equal to 0 at, if you look at the unit circle, at 0 degrees and at pi degrees, which is 180. Because they want our answers in degrees. So now what would I do with the 5? You're going to divide, right? It's like 5. So if you had like 5x equals 0 or 5x equals 180, if you divide it by 5, you would get 0 and 36, which is the answer. So we don't want the 0 for this one because in degrees, well, 0 is not an angle, so it has to be greater than 0 for these. So for every 36 degrees, sine of 5x equals 0. And that's the answer for this one. So just try your best with this worksheet. I know it could be a little tricky. Let's see how we do. Unfortunately, I cannot make videos longer than like 15 or 20 minutes. It won't let me upload it on the site because it's too long. So I try to make these videos pretty simple, short, to the point. But if you do need, you know, like an additional videos, or if you're confused on something specific, let me know. Use the PhotoMath app to help. But yeah, if you're confused, still need more examples, just let me know. Good luck.